So we're going to look at the second assignment in 2.2. So we're going to start with number 9. Sine squared of alpha minus sine to the fourth of alpha equals cosine squared of alpha minus cosine to the fourth. Now people get really scared as soon as they start to see this to the fourth power because there's nothing in on our ticket that is anything to the fourth power, so we have to factor this somehow. We do have the difference of perfect squares, and we do have greatest common factor. In this case, the greatest common factor really helps us out a lot, because when I factor out a sine squared, I get 1 minus sine squared of alpha, which will right away, I can replace 1 minus sine squared with cosine squared of alpha. Okay? And that leaves me with sine squared of alpha times cosine squared of alpha. So it looks really similar to what I have on the other side, so we'll follow the same pattern. If I factored out a cosine squared, I get 1 minus cosine squared of alpha, which I can automatically substitute in for that sine squared. So that's really going to help me out. And making sure both sides match up. So not a bad problem, but again, greatest common factor. That's the trick I use in order to make it work. So number 12 is going to start off like this. And the first thing I notice is if I go to the right side, I can replace cosecant squared of t minus 1 as cotangent squared. And then if I look on the left side, I definitely have a cotangent squared, but it would look like this. I'd have a 1 over, I would have a cotangent. I'm going to make this work here. I would have a cotangent of t over a cosecant of t, and that would leave me with a cotangent squared of t over 1. If you look at the top, the cotangent to the third power, I just split up. So now the question is, can I make cosine equivalent to cotangent divided by cosecant? So let's give it a try. Cotangent is cosine over sine divided by cosecant is 1 over cosine. Sorry, I was just joking. Cosecant is obviously 1 over sine. Alright, so if I'm going to multiply that out, oh man, I think really good things happen. I have cosine over sine times, and I have to take the reciprocal, which would be sine over 1. So that would leave me with cosine. So let me make sure I highlight this a little bit. Just looking at this piece right here, I went all the way through, and I know that this cosine is equivalent to this cosine. Therefore, I am all set. Sweet. Alright, number 14 is a classic problem that you will see a whole bunch. So if I look here, it looks to me like I have a fraction going on over there. So if I have a fraction, I'm going to need to get a common denominator. And in this case, my common denominator is going to be the sine. So I have to multiply top and bottom by the sine. So if I look, I have 1 divided by sine of x minus sine squared of x divided by sine of x. And this is awesome. My denominators are the same, so I can just go ahead and add. I have 1 minus sine squared of x on top divided by sine of x on the bottom, and 1 minus sine x, 1 minus sine squared is the same thing as cosine squared over sine of x. Again, if you see the common denominator right from the beginning, then it makes your life a whole lot easier. So I think number 26 is one of the tougher problems you guys have to do, and what makes it tough is getting this common denominator from the beginning. So we're used to writing just using the other denominator in order to make it work, which would be 1 plus the sine of theta. But what you're going to notice if you do that is not a whole lot of stuff is going to cancel out for us. So I'm actually going to, not that you can get there doing that, but I'm going to do this a little different way. So one thing that I'm going to notice is if I multiply this by cosine, that's going to give me a denominator of cosine squared. So if I take a look at this side, I will get cosine squared of theta on the bottom, and on top I have cosine of theta plus cosine times sine. Now if I look at my other side, I'm going to also need to get a common denominator over there. In order to make it cosine squared, I have 1 plus the sine, so I'm going to do 1 minus the sine of theta. And 1 minus the sine of theta on that side. What this is going to do for me is in my denominator I have 1 minus sine squared. So if I use the conjugate, I'm able to get back to that binomial, because 1 minus the sine squared is the same thing as the cosine squared of theta. And then on top, this helps out. I get a cosine of theta, and then I get minus cosine of theta times sine of theta. Now the great part about this is you already see the plus and the minus here. So I have plus cosine of theta and minus cosine of theta. So I can eliminate both of those, which makes my life much easier. So if I come down here, I have cosine of theta over cosine squared of theta, and then on this side I have cosine of theta, which when I finish this off I have 2 cosine of theta divided by cosine squared of theta. So great part about this is we can start to reduce. I have 1 cosine up here and 1 there. So my finished product is going to be 2 over the cosine of theta, which is the same thing as my original 2 secant of theta.